Greetings. My name is Tim Stark. I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. I'm recording videos to demonstrate the ASTM test methods to measure the index and certified properties used to assess or evaluate geomembranes for environmental containment applications. Today I will demonstrate ASTM test method D1790, standard test method for brittleness temperature of plastic sheeting by impact. This test method is used to predict the behavior of plastic sheeting, geomembranes, at low temperatures. This test method is useful for specification testing or comparative purposes, but does not necessarily demonstrate or determine the lowest use temperature for a particular sheet or geomembrane. The specimen used for the test is shown here. It has dimensions of 50.8 millimeters and 146.1 millimeters, and that's 2 inches by 5 3/4 inches. It is folded into a loop, as you see here. The folded loop is attached to a paper card that is 2 inches by 5 inches. The paper card assists handling the specimen, placing it into the freezer and taking it out of the freezer after it is subjected to minus 29 degrees Celsius for 15 minutes. The geomembrane specimen is attached to the paper card by 2 staples. These are standard office staples. These staples are 1/2 inch from the edge of the geomembrane and the card. The specimens are taken from a geomembrane roll in the machine direction, but the specimen, the long dimension of the specimen, is in the transverse direction. So 10 of these specimens are taken in the machine direction like this. And the longest dimension of the specimen is in the transverse direction. So the specimen is 146.1 millimeters in the transverse direction and 50 millimeters in the machine direction. And there are 10 of these taken down the roll. The specimen is placed in the impact hammer that's shown here. I'll place the hammer at a right angle using a triangle, and that'll hold it in place. And now I place the specimen from the freezer with the 2 staples in the slot at the impact point. The specimen has been in the freezer for 15 minutes at minus 29 degrees Celsius. The impact hammer has been in the same freezer for 1 hour. The test can be performed inside the freezer. In the bottom of the freezer, place the specimen on the impact block, and now I'm going to move the hammer 0 to 5 degrees from vertical so it falls on the geomembrane specimen that has been subjected to minus 29 degrees Celsius for 15 minutes. So here goes the hammer. The hammer is lifted back up to vertical, and the specimen is pulled out after the test. You can see the specimen is creased, but it has not failed. And failure is a partial break or failure or a complete failure. This specimen is intact, so this passes the low temperature impact test of ASTM D1790. This specimen did not pass the impact test. You can see that the specimen split. The loop is discontinuous, and so this is a failed specimen after low temperature conditioning. The data sheet for the test is shown here. So the test I just ran passed, so brittleness test pass, yes. I will repeat that for 9 more specimens oriented in the transverse direction but taken in the machine direction along the roll. So I will make up some results. Yes, yes, no, yes, yes, no, yes, yes, no. So I have 3 no's of 10 tests, so my percent passing would be 70%. What's required by the specification is greater than 50% passing. So this geomembrane would pass the low temperature impact test of ASTM D1790. That's all there is to the low impact temperature test. If you have any questions, please email me at fabricatedgeomembrane@gmail.com or visit our website at fabricatedgeomembrane.com.